Hello and welcome to my science tutorials. In today's video, we want to look at pressure in liquids. So without further ado, let's begin. So what is pressure? We know that pressure can be defined as the force per unit area, that is the force per unit area, which means mathematically we can say pressure P is equal to force over area. Now when we talk about pressure in liquids, we are talking about the force per unit area that the volume of liquid exerts on the vessel or the container in which that liquid is. Now this force or this pressure that is exerted on the vessel is what we call the hydrostatic pressure, right? So for normal solids we just call it pressure, but for liquids we call it hydrostatic pressure. Now this hydrostatic pressure depends on three things, so let's look at them. So the first thing that pressure in liquids depends on is the density of the liquid. So we have density of the liquid. The second thing it depends on is the height of the liquid. So we are looking at the height of the liquid. And lastly, if we look at the last one, is the acceleration due to gravity. So acceleration due to gravity. So which means the pressure in a liquid depends on the density of the liquid, the height of the liquid in the container, and lastly the acceleration due to gravity of that particular liquid. Acceleration due to gravity, sorry. Now let's consider how the pressure that we are talking about depends on the density, the height, and the acceleration, whether it is directly proportional, inversely proportional, or how they relate to each other. Let's look at that. So we want to talk about the calculation of pressure in liquids. So calculation of pressure in liquids. Okay, so let me quickly get rid of these guys over here. All right, so let's say we have a container that looks like this, a very beautiful container, right? Obviously not drawn to scale, right? So we have from here to here is the height. This is the height, right, of the water in the container. We have here to be the area, right, the area of the container, and then we have the density or rho. This is the density. So we are to consider a liquid of density rho, which we have over here, contained in a vessel with a cross-sectional area A, right? So the area is in meters square, and the depth in H in meters. All right, so let's look at some parameters. Let's look at the volume of the liquid, right? Now to get the volume of the liquid, we need to multiply the area or the base area by the height. Okay, so we use the area over here to multiply the height, and this will give us the volume, which means volume is equal to area multiplied by height. All right, now let's look at the mass of the liquid. So I'm going to represent this ml, that is mass of the liquid. So the mass of the liquid, we can obtain that from the density of the liquid. So we know density or rho is equal to mass, or the mass of the liquid, mass over volume, right? So if we make ml the subject, we are going to have density multiplied by the volume, right? But remember, we made the point at the top over here that the volume is equal to the area multiplied by the height. This implies that in place of the volume over here, the mass of the liquid will be density multiplied by area multiplied by height. Okay, now let's continue with our deduction. Now I'm going to erase this illustration over here, but it's actually very important. All right, now that we have the volume, now that we have the mass, let's look at the weight of the liquid. The weight. Now if you look at it, the weight of the liquid, or the weight, is mass multiplied by acceleration due to gravity. Okay, so which is m multiplied by g. But we know that the weight of the liquid, which is equal to mass multiplied by gravity, are you okay? The mass is equal to density multiplied by area multiplied by h. So in place of the mass over here, I'm going to have density multiplied by area multiplied by h multiplied by g. This is equal to weight. Now we know that weight is equal to force, right? Weight is the same as force, so which directly means that this whole thing that we have over here, which is the weight, is the same as the force. So the force is equal to the density multiplied by the cross-sectional area multiplied by the height and multiplied by gravity. Now let's make the final deduction over here. Now let's look at something. Now we said that pressure is equal to force over area. Now we agreed that the force we have, okay, or the force of the liquid, is equal to the density rho multiplied by the cross-sectional area A multiplied by height and multiplied by gravity, all divided by area, which is A. So if we look at it over here, the area will cancel the area over here, and therefore our pressure will be equal to, the area has cancelled the area, so we have the density multiplied by height multiplied by gravity. So this is the expression that we want, or this is the expression that we are looking for, or we'll be using in our calculation. Remember, at the beginning of this video I said that the density, or the hydrostatic pressure, depends on the density of the liquid, the height of the liquid, and acceleration due to gravity. And this is the relationship. They are directly proportional to each other. Okay, so from the expression derived for the pressure exerted at the base, we realize that the pressure exerted depends on the height of the liquid column but not the area. Okay, so we can see that the pressure over here in liquids does not depend on the area, because there's no area in the formula over here, right? Unlike in solids, where it depends on the area. The smaller the area, the higher the pressure. In liquids, it does not depend on the area, but rather the height of the column or the vessel in which we find the water. So all right, so now that we have this basic understanding, we know that this is the formula that we are going to use to calculate our pressure in liquids. Let's have a look at some examples or some questions to further deepen our understanding of our concept, or of this concept, pressure in liquids. Right, so let's look at example number 1. So the base area, or the base of a rectangular vessel, measures 10 centimeters by 18 centimeters. Water is poured into a depth of 4 centimeters. What is the pressure at the base? We have to calculate the force exerted on the base. We have to take the density of water to be 1,000 kilogram per meters cube, and then gravity to be 10 meters per second squared. All right, so let's go ahead and look at the solution to this problem. So write down our solution. Okay, so we were told that the base of the rectangular vessel has a dimension, so I'm going to use the dimension to be equal to 10 centimeters by 18 centimeters. So 10 by 18 centimeters, right? So if I convert this straight ahead to meters, right, just so that I don't have to do conversion later on when I'm doing the calculation, 10 centimeters to meters, I divide by 100. So I'm going to have 10 divided by 100. That's going to give me 0.1 meters. multiplied by 0.18 meters. That is the conversion for both that I have over here. Now, water is poured into a depth of 4 centimeters. So the depth or the height is 4 centimeters over here, which is equal to, if I convert it to meters, I divide by 100, so that will give me 0.04 meters, right? And then we were asked what is the pressure, so we don't know the pressure, and we were told to calculate the force as well. We do not know the force. We're given the density of water, rho, to be equal to 1,000 kilogram per meters cube, and gravity, acceleration due to gravity, to be equal to 10 meters per second squared. All right, so let's go ahead and calculate the pressure for this particular problem. Now, if we look at the formula that we derived earlier on for pressure, we said pressure is equal to the density multiplied by the height multiplied by gravity. So there's no need we calculate area here. So if we look at it, pressure will be equal to the density is 1,000, 1, 2, 3, multiplied by the height in meters, 0.04, then multiplied by gravity, which is 10. So if I compute everything into my calculator, 1,000 multiplied by 0.04 multiplied by 10 will give me 400 Pascal as my pressure. So this is the pressure that I get. Now, the second aspect of the question is saying we have to calculate the force exerted on the base. All right, so we know that pressure equals force over area. Okay, that's the normal formula. But we have the pressure, we know it's 400 Pascal, right? We're asked to find the force, which we do not know, but we can calculate the area from the dimension of the base given. So the area here will be equal to 0.1 over here multiplied by 0.18, which is going to give me 0.018 meters square as my area for the base. So now that I have the area of the base, and then I was asked to find force, I can make force the subject here. So making force the subject, I will have pressure multiplied by area. This is equal to, the pressure is 400 Pascal from here, and then the area is 0.018. So 400 multiplied by 0.018 is going to give me a force of 7.2 newtons. Okay, so this becomes the force exerted on the base of this particular rectangular vessel. All right, so now let's look at the second example. Example number 2. A tank is 1.5 meters deep and is full of water. We have to calculate the pressure at the bottom of the tank due to the liquid, given that the density of the water is 1,000 kilogram per meters cube and acceleration due to gravity is 10 meters per second squared. All right, so this is a fairly easy example. So let's look at the solution. So we're given the height of the tank to be 1.5 meters. Since the water is full, right, it means the height of the water is also 1.5 meters. Or since the tank is full, the height of the water is also 1.5 meters. So the height here is the height of the water. So we have to calculate the pressure. So we don't know the pressure at the bottom of the tank. We're given density to be 1,000 kilogram per meters cube, and then acceleration due to gravity to be 10 meters per second squared. Now we know that pressure in liquid is equal to the density multiplied by gravity multiplied by the height. That is for pressure or hydrostatic pressure. Now we know that the density over here is 1,000, acceleration due to gravity is 10, and then the height is 1.5. It's already in meters, so it is very good for us. So if I multiply 1,000 by 10 and by 1.5, I'm going to get 15,000 Pascal, right? Which is equal to 15 kilo Pascal or 15 bar. So let's look at another example to further understand this concept of pressure in liquid. Let's look at a very technical question. That's the third example. So this third example, I would like you to pay very close attention because it requires that we do quite a number of things, and you have to pay full attention and then use your head around the question. So let's go ahead and have a look at the question. So water from a leaking tap begins to fall into an empty tank of 0.5 meters wide by 2 centimeters long by 4 centimeters high. If the water drops, okay, fall at a rate of 2 drops per second, and if each drop weighs 0.05 gram, after how many seconds will the pressure at the bottom of the tank be 200 pascal? Okay, we're given the density of the water to be 1000 kilogram per meters cube, and then acceleration due to gravity as 10 meters per second square as usual. Right, so the first thing I do is I write down my solution, and then I collect the parameters or the things that have been given in the question. So the water from the leaking tap, okay, begins to fall into an empty tank of 0.5 meters wide. So the dimensions that I have is 0.5 meters wide, okay, by 2 centimeters. Sorry, this is 2 meters, so it's supposed to be meters, not centimeters. So it's by 2 meters wide, okay, and then this is also supposed to be in meters, so apologies for that. So it is 0.5 meters by 2 meters by 4 meters, right? That is the dimension that I have. So I was told if the drops fall at the rate of 2 drops per second, right? So the rate is 2 drops per second. So let me say rate is 2 drops per second, right? So let me make it 2D. So 2 drops per second is S. Okay, 2 drops per second, and if each drop, okay, a drop, okay, so the weight of the drop is 0.05 grams. Okay, after how many seconds? So where we have to find the seconds, will the pressure be 200 pascal? Okay, given that the density is 1000 as usual, and then our gravity is 10 meters per second squared. All right, so let's have a look at the solution for this particular problem. Now the first thing I would like to do before I tackle the question is to first of all convert my weight from gram to kilogram, or change all the units. Right now I've already corrected the fact that the units are all in meters, so not centimeters, so they are all in meters. That was an error when I was writing the question. So the only thing I need to convert over here to conform to all the units is the weight. So I need to convert it from gram to kilogram. Okay, so from gram to kilogram I need to divide by 1000. So if I divide 0.05 by 1000, I'm going to get, let me write it in standard form, 5 times 10 raised to the power minus 5 kilogram. All right, so that is my unit in kilogram. So now that I have this, I can go ahead and look at the question. Okay, so I know that pressure is equal to density multiplied by height multiplied by gravity. Now if I look at this formula, I know that I have my pressure, which is 200. I have density over here, okay? I have height. I was told that height is 4 meters. I have gravity. So this formula cannot help me get the seconds that I need. So I need to use another formula for pressure. So this formula will not do in this case. So now which other formula do we know for pressure? We also know that pressure is equal to force over area. Okay, now we know that force is what? Mass times gravity. Then we repeat our area. Now from here it means that we can get the total amount or the total mass of the water at 200 pascal. Okay, if we get the total amount or the total mass of the water at this particular pressure, which is the 200 pascal, Then we can use that and use the rate of drop to calculate the seconds that we use to get this particular 200 Pascal. So let me take that again. I said that in order for us to calculate the seconds, okay, that will give us the amount of seconds that has passed and how many or how much water is in the barrel or the container for us to have 200 Pascal. We need to calculate the weight or the mass, okay, let me be specific, the mass of the water in the tank, right? We need to calculate the mass of the water in the tank. Now if we get the mass of the water in the tank, that will give us an idea, since we have the rate at which it was dropping, then that will give us an idea of how long or how many number of drops based on the weight of each drop will give us the particular or the total weight or the total mass. Then we can use that to calculate the other parameters, which is the seconds that we're asked to find. So let's look at this. So pay attention. So we have the pressure, we know it's equal to mass multiplied by gravity on area. Are you okay? So let's do the quick substitution. So our pressure is 200. We've been given here. Our mass, we don't know, because that's the mass of the entire water in the tank that we want to find at the end. Okay, so we know gravity is 10, and then we know that area, the area over here, for us to calculate the area, I use the width and then the length over here, right? Not the height, right? The base, not the height. Okay, so I'm going to use 0.5 multiplied by 2. So I have 0.5 multiplied by 2 because the tank is going to be something like this. Okay, so this is the height, and then the wideness or the width and then the length, right, will make the area at the base over here. So that is what I need. I need the width and the length, right, not the height over here. All right, so from here I have 0.5 multiplied by 2, right, multiplied by 200. So I have 10m, that is from the top over here, will be equal to 200 multiplied by everything I have over here. So 200 multiplied by 0.5 multiplied by 2. So I have 10m is equal to 200 multiplied by 0.5, that will give us 100, multiplied by 2 will give me 200 again. So I now divide both sides by 10, and then my mass will now be, this will cancel this, so I now have 20 kilogram as the mass of the water at this particular pressure, which is the 200 Pascal pressure. Now if the mass is 20 kilogram, we know that per drop is 0.05 grams, or 5 times 10 raised to the power minus 5 kilogram, and the total water we have in the tank is 20 kilogram. So to find the total number of drops that entered into the bucket, we need to divide the 20 kilogram over here by 5 times 10 raised to the power negative 5 to get the number in terms of drops, how many drops of water came to form this particular mass. So let's look at that. So the total mass over here, the total mass we have is 20 kilogram. So we have 20 kilogram. Then we divide that by the weight of one drop to get the total number of drops that we have in the tank. So we divide by 5 times 10 raised to the power minus 5, right? So number of, let me make this number of drops, ND, is equal to, now ND, number of drops, will be equal to 20 divided by 5 times 10 raised to the power minus 5 will give me 400,000. So I have 400,000 or 400k. So this is 400,000 drops, right, will give me this particular weight, which is 20 kilogram, and that 20 kilogram will give me a pressure of 200 Pascal at the bottom. Now remember that the question is saying that we should find how many seconds, okay, it will take for the pressure to reach this. Now we know that it will take 400,000 drops, right? And we know the question gave us that 2 drops counts per second, right? 2 drops per second, 2 drops per second. And we know the total number of drops, right? We know that we have 400,000 drops. Now if I divide 400,000 drops by 2, that will give me the amount in seconds, right, that will give us this total of 200 Pascal. So the time in second will give me, okay, let me make time in seconds, so make it TS, right? Time in seconds will give me ND, the total number of drops divided by the rate. So our time in seconds will be the ND, which is 400,000, divided by the rate, which is 2 over here. So if I do that, if I compute this into my calculator, 400,000 divided by 2 will give me 200,000. So 200,000. So it means it is going to take 200,000 seconds for this particular drops one by one to fall into this tank to reach a mass of 20 kilogram and to exert a pressure of 200 Pascal at the base of the tank. So thank you so much for watching. This is how we calculate the pressure at the base of a particular container or tank if we have a liquid in that particular container or tank. So thank you so much. This is how we calculate pressure in liquids, and I hope you found the video useful. If you do, kindly make sure you subscribe to the channel and turn on the notifications so that you don't miss any of the latest videos from my science tutorial. So once again, thank you, and I'll see you in the next video. Bye bye.